Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we will be completing our last set of notes for Section 3, Chapter 1, Solving Equations with a Variable on Both Sides. In this section, we're going to take a look at some special cases that can occur when we solve an equation. So when we solve an equation with variables on both sides, it is very possible that we get some equations where the variables cancel out completely. And this can result in equations where we get an answer of infinitely many solutions or an answer of no solution. So we want to talk about, well, how do we know if it's infinitely many solutions or no solution? And what exactly does that mean? So when you're solving an equation, if your variables cancel out completely, meaning you no longer have any variables on the left side of the equals and you no longer have any variables on the right side of the equals, all you have is numbers in the problem, no letters whatsoever. When that happens, okay, your variables are completely gone, then one of two things will occur. You either will have a true statement or a false statement left. So I first want to take a look at a true statement. So a true statement would be something like 5 equals 5. If something like that were to occur, your variables are gone, but you have a number equal to itself, that's true. That would mean that our answer is going to be infinitely many solutions to the equation. And what that means is that we can plug in any number for x and that equation will work. So it's just telling us that there's so many solutions to this problem, we couldn't write them all down. There's infinitely many. However, if a false statement occurs, such as 7 equals -2, they're different numbers, they're not equal to one another, then we call that no solution. And no solution means that there is no number that will work to solve the equation. So we're going to take a look at some actual examples now so you can see how this truly works. So our first example is 4x plus 6 equals 2 times the quantity 2x plus 3. So we're going to solve these equations like we would solve a normal equation. So on the left-hand side, 4x plus 6, there's nothing we can do yet. So we're just going to drop down 4x plus 6. And what we're going to do to start this problem is on the right-hand side, we want to get rid of the parentheses by distributing the 2. So 2 times 2x would be 4x. And 2 times 3 would be plus 6. So once I've distributed and cleared my parentheses, I'm looking to see do I have any like terms on the left or on the right. In this case I don't. I have a single x and a number on each side. So what I'm going to do is get the variables on one side. So I have 4x and 4x. Since it's the same, it honestly doesn't matter which one I move. They're both positive. I'm going to need to subtract 4x to move these variables because that's the opposite of a positive. Now when I do this, on the left the 4x is canceled, so I'm left with 6. And on the right the 4x is canceled, so I'm left with 6. So you see I no longer have any variables in this problem because all of them canceled out completely. So I have 6 equals 6. When this happens, your variables are completely gone and you're just left with numbers. You want to ask yourself, is what's left a true or false statement? So 6 equals 6. Well, that's a true statement. And anytime we have a true statement as our answer, we're going to say that this is called infinitely many solutions. So our answer to this equation is infinitely many solutions. What that means is we could plug in any number for x and the left side would equal the right side. So a true statement after all the variables canceled out is called infinitely many solutions. Our second example is 6x minus 5 equals 2 times the quantity 3x plus 4. For this problem, again, we're going to solve it like any normal equation. So what I'm going to do is on the left-hand side, drop down the 6x minus 5 because there's nothing I can do with those quite yet. And on the right-hand side, I'm going to distribute my 2 to get rid of the parentheses. So 2 times 3x is 6x. And 2 times 4 is plus 8. So I have 6x minus 5 equals 6x plus 8. So now, since there are no like terms on either the left-hand side or the right-hand side, I'm going to get my variables on the same side. So I have 6x and 6x. The opposite of 6x, a positive, would be to subtract, or a negative. So we're going to subtract 6x on both sides. When I subtract 6x on both sides, I'm left with negative 5 on the left. And since they also cancel on the right, I'm just left with 8. So again, remember, when the variables are gone completely, once you do the addition or subtraction, it canceled all the way out. You're just left with numbers. You want to ask yourself, is that true or false? So negative 5 equals 8. Well, that's false. They are not the same number. And anytime it's a false statement, we call that no solution. So no solution would be our answer to this problem. That means there is no number we could plug in for x to get the left side to be the same as the right side. So our answer for this equation is no solution. It is now time for your first U-try. Please pause the video and attempt the following problem. When you have an answer, resume the video to check it. To solve this equation, what we first want to do is distribute on the right-hand side of the equation. So since nothing's going to happen on the left-hand side right now, we're just going to drop down t minus 27. And on the right-hand side, we're going to distribute the negative to the 27 and the negative t. Now, many people get confused when there's a negative. So remember, that's just like it's a negative 1. So negative 1 times 27 and negative 1 times negative t. So negative 1 times 27 would be negative 27. And negative 1 times negative t would become positive t. So once we've distributed, there are no like terms for us to combine. We're going to get the variables on the same side. So I have 1t and 1t. So the opposite of 1t would be to subtract 1t on both sides. So I'm going to be left with a negative 27 on the left, and I'm going to be left with negative 27 on the right, because the 1t minus 1t canceled on both sides. So once the variables cancel out completely, you want to ask yourself, are you left with something that's true or false? Well, negative 27 is equal to itself, so this is true. And remember, when it's a true statement after variables have canceled out, we say that the answer is infinitely many solutions. In other words, that means we could plug in any number for t, and that number would work to make the left side the same as the right side. So our answer to this problem, infinitely many solutions. And this is your second U-try. Please pause the video and attempt this problem. When you have an answer, resume the video to check it. To solve this equation, we want to distribute the 16 on the left-hand side of the equation. So 16 to 4 and 16 to negative 3m. 16 times 4 is 64. And 16 times negative 3m would be negative 48m. Now, if you do not know those numbers on the top of your head, it is more than okay to multiply them out off to the side of your paper. On the right-hand side, I'm just going to drop down negative 48m minus 96. So now that I've distributed and there are no like terms to combine on the left or the right, I'm going to get the variables on the same side. So I have negative 48m on the left and negative 48m on the right. So the opposite of a negative 48m would be to add 48m to both sides. When I add 48m to both sides, on the left, the 48m's cancel, so I'm left with 64. And on the right, the negative and positive 48m cancel, so I'm left with negative 96. Now, 64 equals negative 96. I see there's no variables left in my problem. So when this happens, no variables, I want to ask myself, is this true or false? Well, 64 is not the same as negative 96, so this is false. And anytime the variables cancel out completely and our numbers are not the same as each other, we have a false statement, then we say our answer is no solution. So our answer to this equation is no solution. That means there is no number that we could plug in for m to get the left side to be the same as the right side. Please do not think that you can no longer solve an equation and get a number as your answer. The purpose of today's notes were just to introduce you to the two special cases of no solution and infinitely many solutions. This now concludes our lesson on part 4 of section 3 of chapter 1, solving an equation with variables on both sides. If you have any questions, please ask Miss Brooks. Thanks for tuning in, and we'll catch you next time on your Daily Dose of Math with Miss Brooks.